What's up with dice and why are they so weird? In 3800 BC Sumer, early man, at the dawn of his informational evolution, figured out something that has eluded most of us since that day. All dice that humans use in today's modern gaming have a random chance of rolling the same thing every time you use them. Dice by today's standards are basically dummy objects. Your chances of rolling a 3 on a 6-sided die are 1 in 6 every time you use them. The expectation is very simple and plain, but not in 3800 BC. Back then, Sumerian mathematicians figured out a way to build dice that actually behave a certain way and to allow a higher decision-making process when thinking about a game. How can this be? How did they do this? Well, at Ghosts of Ur LLC we take a deep dive into how they did this and mathematically how these dice roll some numbers more than others. Is there an equal chance of each score happening with these dice? First, each die was a 4-sided equilateral pyramid. 2 of the 4 corners were marked white. This meant that when a die was rolled, there were 2 chances in 4 of getting a white corner. P white equals 2 of 4 equals 1 of 2. Next, so the probability of rolling 1 if a white corner counts as a 1 is P white equals 2 of 4 equals 1 of 2. Next, if a player has 4 pyramid dice to roll, then a 0, 1, 2, 3 or 4 could be rolled. Is there an equal chance of these scores happening? Next, we will draw a tree diagram to help us answer this question. A white corner will be represented by a W and a black corner with a B. Every white at the top after a throw counts as 1. This would count as 0. Further, in the tree diagram there will be 4 events matching the results of the 4 dice thrown. WB first dice P white equals 2 of 4 equals 1 of 2. P black equals 2 of 4 equals 1 of 2. 1 of 2, 1 of 2, so the chance of rolling a 1, a white tip, is 1 chance in 2. Next, when the second pyramid is rolled, once again there is a 1 chance in 2 of getting another white tip. The chance of getting 2 white tips, rolling a 2, is found by multiplying along the branch of the tree diagram. This means that the chance of rolling a 2 is 1 chance in 4, times 1 of 2 times 1 of 2 equals 1 of 4. Next, the same can be done for each branch of the tree. Times probability of rolling a 2 is 1 of 4, probability of rolling a 1 is 1 of 4, probability of rolling a 0 is 1 of 4. Next, since there are 2 possibilities of rolling a 1, we add the fractions. This gives a 2 of 4 or 1 of 2 chance of rolling a 1. The combined probability of rolling a 1 is 1 of 4 plus 1 of 4 equals 1 of 2. Next, here is the tree diagram for rolling the 4 pyramid dice. First die, second die, third die, fourth die. Further, here is the tree diagram for rolling the 4 pyramid dice. First die. Further, here is the tree diagram for rolling the 4 pyramid dice. First die, second die. Further, here is the tree diagram for rolling the 4 pyramid dice. First die, second die, third die. Further, here is the tree diagram for rolling the 4 pyramid dice. First die, second die, third die, fourth die. Next, since each arrow has a probability of 1 of 2 and we multiply along a branch to find the chance of that branch occurring. Each branch line has a probability of 1 of 2 times 1 of 2 times 1 of 2 times 1 of 2 equals 1 of 16. Follow 2 branch lines to see how this happens. Next, first die 1 of 2. Next, first die, second die 1 of 2, 1 of 2, 1 of 2, and so on. Next, first die, second die, third die. Next, first die, second die, third die, fourth die. Next, first die, second die, third die, fourth die, 1 of 2x, 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 1 of 2 equals 1 of 16. Next, the probability of each branch occurring can be written like this. P, W, 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 W equals 1 of 16. P, W, B, B, B equals 1 of 16. This can be done for each branch of the tree. Next, only one branch of the tree will give a roll of 4, so the chance of rolling a 4 will always be 1 of 16. Next, but what about the chance of rolling a 2? There are 6 branches that have 2 whites, a score of 2. Additionally, but what about the chance of rolling a 2? There are 6 branches that have 2 whites, a score of 2. To find the probability of rolling a 2, add the chances of each of the 6 branches. Then, the chance of rolling a score of 2 is 1 of 16 plus 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 1 of 16 equals 6 of 16. Finally, by doing this for each of the possible outcomes, 0, 1, 2, 3, or 4, the probabilities for each option turn out to be P, 0 equals 1 of 16 or 6.25%. P, 1 equals 4 of 16 or 25%. P, 2 equals 6 of 16 or 37.5%. P, 3 equals 4 of 16 or 25%. P, 4 equals 1 of 16 or 6.25%. So our original question was, is there an equal chance of these scores happening? The answer, no. From all this we can conclude two things. First is that early man was a lot smarter than anyone gives him credit for. And second, shameless plug here, that Ghosts of the new tabletop game that utilizes these old dice, coming to Kickstarter spring of 2022, is going to be awesome.